My name is Redford Bong. Today, me and my colleague Palina Misto will present to you our research. The title of our research is Effect of Number of Screws on Connection Strength and Mode of Failure in Cold-Form Steel Hybrid Connections. The increasing application of cold-form steel (CFS) in the construction field is due to its advantageous characteristics. CFS is lightweight with high durability and high strength, and it is also made with solid material consistency with corrosion-free properties. The increase in recent research and the diversity of commercial applications dealing with the use of CFS structures in the construction industry was actually initiated at the end of the 1990s with the introduction of a roofing steel frame system for residential buildings. The two main methods for jointing structure are adhesive bonding and mechanical fastening. Every method has its advantages and its inconveniences. In construction projects where CFS is used, fasteners such as bolts and nuts are commonly used. Other commonly utilized fasteners are self-drilling screws (SDS), which are used to make connection to metal cladding roof, as well as specialty roofs such as framing members. Adhesive joints are also used in various industries because of their advantages over mechanical fastening such as riveting, welding, and bolting. A new connection method on CFS that combines self-drilling screw and adhesive for CFS connection or hybrid connection potentially offers an increase in connection strength. In order to improve the understanding of the behavior of CFS hybrid connections that could lead to effectiveness of connection design, factors such as number of screws used in CFS connection and mode of failure need to be investigated. The problem statement for our research are as stated below. SDS connection flaws in CFS structures could lead to weaknesses in the construction area, thus reducing the load-bearing capacity of the structure. The combined effect of element weakness and connection weakness on the CFS structure often lead to a premature collapse of the structure. To avoid such damaging outcome, a new connection method on CFS that combine self-drilling screw and adhesive for CFS connection or hybrid connection potentially offers an increase in connection strength. Thus, the aim of this study is to determine the relationship between the number of screws and connection strength and to determine the mode of failure in CFS hybrid connections. The research objectives are as stated below. Number 1. To determine the relationship between the number of screws and connection strength. Number 2. To determine the mode of failure in CFS hybrid connections.
My name is Palina Misto. I will continue this presentation for methodology, data collection, data analysis, result discussion, and recommendation. So in this research, we use quantitative research. For data collection, the data was obtained from the experimental data from the shear test, and the data was analyzed using statistical analysis SPSS 26 version. A total of 36 specimens of CFS hybrid connection, single leg joints with varied number of screws were tested in the laboratory. The number of screws varied between 2, 3, 4 screws. Leg thickness varied from 0.75, 1.0, and 1.2 mm, and the bonding length is 80 mm with adhesive thickness of 0.5 mm. All specimens were tested under tensile loading, and the maximum load recorded in this study is taken as the connection strength of the specimen. The failure modes were observed and the collected test data were analyzed. For objective number 1, which is to determine the relationship between the number of screws and connection strength, a statistical analysis using the Pearson correlation test was conducted to determine the relationship between the number of screws and connection strength. There are two hypotheses proposed. The null hypothesis, there is no significant relationship between the number of screw and connection strength. And the alternative hypothesis, there is a significant relationship between the number of screw and connection strength. A significant value is used to determine the significance of the result. If the significant value is less than 0.05, it is statistically significant and indicates strong evidence against the null hypothesis. So for the result for objective number 1, as you can see here, the significant value for all specimens is less than 0.05 of the significant level. Hence, the null hypothesis is rejected and alternative hypothesis is accepted. As for conclusion, a statistically significant correlation exists between the number of screw and connection strength of the section of CFS. Increases in the number of screws were correlated with increases in connection strength. For objective number 2, which is to determine the mode of failure in CFS hybrid connection, eye observation of specimen from shear test was conducted. These are the experimental photo taken from the shear test. As you can see here, the mode of failure begin with the cohesive failure and then following by the tilting failure. For objective number 1, which is to investigate the effect of number of screws, in this research, a significant correlation exists between the number of screws and connection strength in hybrid connection. An increase in the number of screws correlates with an increase in connection strength. And for objective number 2, which is to determine the mode of failure, there are two failure, cohesive failure, and then followed by the tilting failure. In this study, the mode of failure for hybrid specimen involved cohesive failure, which is followed by the self-drilling screw tilting failure. This finding was similar with other researchers that investigated the failure mode in CFS connection. For recommendation, number 1, to conduct an experiment using different types of self-drilling screw and focusing on other parameters such as different diameter, length of self-drilling screw, and type of screw head. For second recommendation, to carry out finite element analysis for hybrid connection by evaluating a model of connection using finite element software. So that's all from us. Thank you for your attention.